Good morning, everybody. Our friends are telling about the what is the linear transformation and what are the applications of linear transformations and how to use linear transformation to solve real world problems. So I have created a software named Linear Transformation Visual Lab. It will take around half an hour to build it. I built it using CSS, Java, and HTML, and I will use some basic logic. So I will break down the software, how the linear transformation will work, and how the element will transfer, and how the graph is plotted, and where we will find eigenvector and eigenvalue. So we will start with basics. I will write the basics formula. We will take a vector like this, x dash and y dash, right? And we will take a matrix here, A, B, C, and D, and we will use some default coordinates, that is x and y. I will tell what are the coordinates that is inputted in the software to calculate the linear transformations of elements. So this is basic, and we will convert it. We will make it more easier. Like x dash is equal to ax plus by, and now the y dash, which is equals to cx plus d. So this is the basic equation. What this equation tells? This equation tells the new position of x and y. Here, see, this is the normal position, that is x and y. Here it is overlapped, so the matrix is like that. The axis will overlap after the transformation, so it is not seen. This is the basic coordinates, and this is the new coordinates that will select the endpoint. Like if we take 2, 3 and 4, 6 here. 2 is starting point of x and 4 is ending point of x. 3 is starting point of x and 6 is ending point of x. So this line, this is here. Here it will calculate the coordinates using the basic coordinates, that is common coordinates used in the software to create like transformation software, like mathematics software. I will tell about the coordinate. So this is the basic logic I have used in the program. So I will give it as equation 1 and equation 2. Okay. So this is the basic logic. Now we will move on to the next part, mathematics. So in previous we see that how we calculate the equation and how we apply the basic law. Now we will move on to that. What are these? A, B, C, D. Here you will see the A, B, C, D values respectively. Here A value is 1, B value is 1, C value is 0, D value is 1. C value is 0. So C's component is x, right? C's component is x, and here it is overlapping the x-axis. So this logic works. Slightly this logic will work. We will use. I will tell that we will use a common domain, like common vector, for all calculation of the linear transformation. The common vectors I will write down. I will take the common vector like this, right? X and y, right? We will see what are the x coordinates we will take as a common. Like the computer screen is consist of like 400 by 600, so we will take 100 because this is a small graph. When we give the large amount of elements like 13, 15, 14, the graph will move on like infinite structure. It will give infinite graphs. So what we will do? We will take some like x as 100, 0, and y as 0, 100. And x comma y coordinate, that is xy, that is 100, 100, and that the vector is decided like this: x, y is equal to 100 by 100. So this is the common vector we have chosen to transform the given vector. we make the graph. You can see the elements here. I will write it A, B, C, and D. Right? Now it is looking like a matrix. Here the 4 elements are there. These elements bear the value. Like if I give that in that graph that A value is 1, B value is 1, C value is 0, D value is 1. Now this matrix that is 1, 1, 0, 1 will multiply with 100 by 100, and what will be the coordinates come, and it will give the new x bar and y bar. So this calculation we have found that the new x position and the y position. Now by all this value the graph is plotted by the software. Now the main crucial part, that is we have not plotted only the graph. It will consider the eigenvectors and eigenvalues also. Like I will tell how. First I will erase it. We will calculate, right? In manual way we will calculate the eigenvectors and the eigenvalues. So like how we calculate the eigenvalue? Like determine some matrix A minus some value lambda into identity matrix is equal to 0. This is the characteristic equation of 2 into 2 matrix to find the eigenvalue, right? By this matrix, I will write here 1, 1, 0, 1. The lambda value becomes 1. By using this equation, we will calculate it. After this calculation, we have to find eigenvectors. The eigenvector formula is given that A minus lambda into I some vector, right? So we used this common two logics that to calculate eigenvalue and the eigenvectors. So this is used as the computer logic. These two formulas used as the computer logic, and it will create the crucial part here, the graph and the plot for the reference. This is reference, and according to the graph, the one line is intersected here and the other line has also intersected here, like 2 lines has intersected here also, and the one single line is intersected here. Okay, here the intersection of 2 points, 2 lines are intersected in this here. See that when the animation is becomes here the intersection, this will produce the eigenvector. This is given eigenvector. From every graph, when we transform, when any matrix is given, when it transforms, we have to find the intersection of the red line and the blue line, which will give the eigenvector of the given matrix. And the eigenvalue, the point, like is somewhere you have to keep like it will somewhere in 2, 3 or 4, 6. Yes, somewhere is. This is eigenvalue of this given graph. So by this, what will the software tell us when we give a matrix? So I will conclude with all this in a single line that finally our software will tell when you give a matrix A, it will multiply with the common given vector, that is xy, and it will produce a graph. From the intersection of graph, and points, we will determine the eigenvector and the eigenvalue. So this is how our software runs, and this is all the process and all the logics is used to determine by the linear transformation visual lab and to create this software. So I hope you have understood this concept and logic behind the software. So thank you for giving your precious time. Thank you so much.